chairman of that committee, and the member for Tangi.
Thank you, Deputy Speaker. Today there are too many questions surrounding science funding, policy and direction. The $20 billion medical research fund, for example, is it going to be general or specifically targeting cancer and Alzheimer's? How are we going to source those researchers? Long lead times are required. And what are we saying to those who want to become mathematicians, physicists or chemists, hard sciences that are already in crisis? The PM asked me to draw up recommendations on science to improve the area. I consulted widely, and these recommendations are now up on my website for anyone who wishes to see them. I'm concerned that we're not putting in place policy to improve science, but we're putting disincentives in place for people who might consider careers in the hard sciences and maths. There appears to be a lack of understanding of how science works. Many advances, including in the medical field, are not the result of directed research, but arise out of more fundamental research that was not directed. X-rays, CT scans and radiotherapy for cancer came from fundamental physics. Magnetic resonance imaging, or MRI, also came from fundamental physics. These were not the result of some effort coordinated by government to achieve a specific breakthrough. They were the result of work driven by a quest for knowledge and understanding that had fortuitous benefits. Consider that 1/3 of the world's economy today is based on the work of what some would consider obscure physicists, mainly German, in the first quarter of the 20th century, nearly a century ago. And here I'm talking about quantum physics and the resulting solid-state electronics, which resulted from the fundamental insights. Consider 19th century physicist Michael Faraday. When asked by then Chancellor of the Exchequer William Gladstone what value electricity had, replied, "Why, sir, there's every possibility that you will soon be able to tax it." Consider general relativity, without which an accurate GPS system would be impossible. How could Einstein have known these applications at the time? How could a government have directed research to that end? One need look no further than Australia, where Wi-Fi came about as a result of radio astronomy research. It came about as a result of a failed experiment into finding atomic-sized mini black holes. In science and research industry, there are many other ways the government can and should participate: by being a customer, funding early-stage R&D, using the bully pulpit to get reticent consumers to trust well-tested technology, and fund an infrastructure bank that uses low-cost government money for well-proven low-risk technologies. Governments have always been lousy at predicting winners, and they're likely to become more so as legions of entrepreneurs and tinkerers swap designs online, turn them into products at home, and market them globally from a garage. The investment architecture is important. How our government treats capital gains can be crucially important to nascent technologies and industries. It can prove the cheap hand up. Cutting capital gains taxes and rewarding long-term commitments will help innovation and invention in Australia. Research and development has much to gain from simple and relatively cheap tinkering at the edges of capital gains tax and superannuation systems. Science and research and development can, and often does, offer attractive returns to investors. If one thinks governments should pick winners, take the NBN as a reality check. Governments have no ability at picking and choosing value-adding projects, and likewise areas for research. Similarly, there is no way of knowing how knowledge will be commercialised in the future. Physician Marcia Angle has shown Many of the most promising new drugs trace their origins to research done by the taxpayer-funded National Institutes of Health in the US, which has an annual budget of some $30 billion. Private pharmaceutical companies, meanwhile, tend to focus more on the D than the R part of R&D, plus slight variations of existing drugs and marketing. Consider the iPhone. It is often heralded as the quintessential example of what happens when a hands-off government allows genius entrepreneurs to flourish, and yet the development of the features that make the iPhone a smartphone rather than a stupid phone were publicly funded. The progenitor of the internet was the ARPANET, a program funded by the Defence Advanced Research Projects Agency, or DARPA, which is part of the Defence Department in the 1960s. GPS began as a 1970s US military program called Navstar. The iPhone's touchscreen technology was created by the company Fingerworks, which was founded by a professor at the publicly funded University of Delaware and one of his doctoral candidates, who received grants from the National Science Foundation and the CIA. None of this suggests that Steve Jobs and his team at Apple were not brilliant in how they put together existing technologies. The problem, however, is that failing to admit the public side of the story puts future government-funded research at risk. State spending on innovation tends to be assessed in exactly the wrong way. Under the prevailing economic framework, market failures are identified and particular government investments are proposed. Their value is then appraised through a narrow calculation that involves heavy guesswork. Will the benefits of a particular intervention exceed the costs associated with both the offending market failure and the implementation of the fix? Such a method is far too static to evaluate something as dynamic as innovation. By failing to account for the possibility that the state can create economic landscapes that never existed before, it gives short shrift to government's efforts in this area. This incomplete way of measuring public investment leads to accusations that by entering certain sectors, governments are crowding out private investment. The charge is often false because government investment often has the effect of crowding in, meaning that it stimulates private investment and expands the overall pie of national output, which benefits both private and public investors. In sum, scientists should not try to game the system, and they should not be reduced to rent-seeking. Research and scientific curiosity should not be dictated by politically hot topics. The 80-20 public-private money equation for research is distracting scientists and preventing them from getting on with their key competencies and important work. This is because ARC funding only funds 80% of a research project. It's the equivalent of a brickie being required to do spend 20% of his time on wiring. Different skill sets lead to suboptimal results. Everyone loses. We need mission-oriented policies that foster interactions among multiple fields. It is time to fund imagination. It's time to invest in unintended consequences, and it is time to invest in known unknowns and, almost more importantly, unknown unknowns.